Subscribe to our channel, and hit the bell icon, to never miss a video from us.
Hi everyone, and welcome back to this course on Selenium. In previous lessons, we had an introduction to Selenium, and learned about Selenium WebDriver. In this lesson, we will learn about Selenium Grid, and why and when to use Selenium Grid. We will take a detailed look into different components of Selenium Grid and how it works. Selenium Grid 4. Selenium Grid allows the execution of WebDriver scripts on remote machines, virtual or real, by routing commands sent by the client to remote browser instances. It aims to provide an easy way to run tests in parallel on multiple machines. Selenium Grid allows us to run tests in parallel on multiple machines, and to manage different browser versions and browser configurations centrally, instead of in each individual test. Selenium Grid solves a subset of common delegation and distribution problems, but will not manage your infrastructure, and might not suit your specific needs. The purposes and main functionalities of Selenium Grid are the following. 1. Central entry point for all tests. 2. Management and control of the nodes, environment where the browsers run. 3. Scaling. 4. Running tests in parallel. 5. Cross-platform testing. 6. Load balancing. Grid 4 takes advantage of a number of new technologies in order to facilitate scaling up while allowing local execution. Selenium Grid 4 is a fresh implementation and does not share the codebase the previous version had. Let us now see how you can get started with Selenium Grid. Several components compose a Selenium Grid. Depending on your needs, you can start each one of them on its own, or a few at the same time by using a grid role. 1. Standalone. Standalone is the union of all components, and to the user's eyes, they are executed as one. A fully functional grid of one is available after starting it in the standalone mode. Standalone is also the easiest mode to spin up a Selenium Grid. By default, the server will be listening on HTTP localhost 4444, and that's the URL you should point your remote WebDriver tests. The server will detect the available drivers that it can use from the system path. 2. Hub and Nodes. Hub and Nodes enables the classic hub and nodes setup. These roles are suitable for small and middle-sized grids. A hub is the union of the following components. 1. Router. 2. Distributor. 3. Session map. 4. New session queue. 5. Event bus. By default, the server will be listening on HTTP localhost 4444, and that's the URL you should point your remote WebDriver tests. One or more nodes can be started in the node setup, and the server will detect the available drivers that it can use from the system path. 3. Distributed. On distributed mode, each component needs to be started on its own. This setup is more suitable for large grids. The startup order of the components is not important, however, following steps are recommended when starting a distributed grid. 1. Event bus serves as a communication path to other grid components in subsequent steps. 2. Session map, responsible for mapping session IDs to the node where the session is running. 3. New session queue, adds the new session request to a queue, then the distributor processes it. 4. Distributor, nodes register to it, and assigns a node for a session request. 5. Router, the grid entry point, in charge of redirecting requests to the right component. 6. Nodes. To run tests after starting successfully Selenium Grid, you can use a remote WebDriver. Let us now discuss when to use Selenium Grid. Generally speaking, there's two reasons why you might want to use Grid. One is to run your tests against multiple browsers, multiple versions of browser, and browsers running on different operating systems. Second reason is to reduce the time it takes for the test suite to complete a test pass. Grid is used to speed up the execution of a test pass by using multiple machines to run tests in parallel. For example, if you have a suite of 100 tests, but you set up Grid to support 4 different machines, VMs or separate physical machines, to run those tests, your test suite will complete in, roughly, 1/4 the time, as it would if you ran your tests sequentially on a single machine. For large test suites, and long-running test suites such as those performing large amounts of data validation, this can be a significant time saver. Some test suites can take hours to run. Another reason to boost the time spent running the suite is to shorten the turnaround time for test results after developers check in code for the application under test. Increasingly, software teams practicing agile software development want test feedback as immediately as possible, as opposed to wait overnight for an overnight test pass. Grid is also used to support running tests against multiple runtime environments, specifically, against different browsers at the same time. For example, a grid of virtual machines can be set up with each supporting a different browser that the application to be tested must support. So, Machine 1 has Internet Explorer 8, Machine 2, Internet Explorer 9, Machine 3 the latest Chrome, and Machine 4 the latest Firefox. When the test suite is run, Selenium Grid receives each test browser combination, and assigns each test to run against its required browser. In addition, one can have a grid of all the same browser, type and version. For instance, one could have a grid of 4 machines each running 3 instances of Firefox 70. When the suite runs, each test is passed a grid, which assigns the test to the next available Firefox instance. In this manner one gets test pass, where conceivably 12 tests are all running at the same time in parallel, significantly reducing the time required to complete a test pass. Grid is very flexible. These two examples can be combined to allow multiple instances of each browser type and version. A configuration such as this would provide both parallel execution for fast test pass completion and support for multiple browser types and versions simultaneously. Let us now look at different grid components and understand their uses. The various components of Selenium Grid are 1. Router, 2. Distributor, 3. Node, 4. Session map, 5. New session queue, and 6. Event bus. Let's discuss about them one by one. 1. Router. The router takes care of forwarding the request to the correct component. It is the entry point of the grid, all external requests will be received by it. The router behaves differently depending on the request. If it is a new session request, the router will add it to the new session queue. The distributor regularly checks if there is a free slot. If so, the first matching request is removed from the new session queue. The router will receive the event and poll the new session queue to get the new session request. If the request belongs to an existing session, the router will send the session ID to the session map, and the session map will return the node where the session is running. After this, the router will forward the request to the node. The router aims to balance the load in the grid by sending the requests to the component that is able to handle them better, without overloading any component that is not needed in the process. 2. Distributor. The distributor is aware of all the nodes and their capabilities. Its main role is to receive a new session request and find a suitable node where the session can be created. After the session is created, the distributor stores in the session map the relation between the session ID and node where the session is being executed. 3. Node. A node can be present several times in a grid. Each node takes care of managing the slots for the available browsers of the machine where it is running. The node registers itself to the distributor through the event bus, and its configuration is sent as part of the registration message. By default, the node auto-registers all browser drivers available on the path of the machine where it runs. It also creates one slot per available CPU for Chromium-based browsers and Firefox. For Safari and Internet Explorer, only one slot is created. Through a specific configuration, it can run sessions in Docker containers or relay commands. A node only executes the received commands. It does not evaluate, make judgments, or control anything. The machines where the node is running does not need to have the same operating system as the other components. For example, a Windows node might have the capability of offering Internet Explorer as a browser option, whereas this would not be possible on Linux or Mac. 4. Session map. The session map is a data store that keeps the information of the session ID and the node where the session is running. It serves as a support for the router in the process of forwarding a request to the node. The router will ask the session map for the node associated to a session ID. 5. New session queue. New session queue holds all the new session requests in a FIFO order. It has configurable parameters for setting the request timeout and request retry interval. The router adds the new session request to the new session queue and waits for the response. The new session queue regularly checks if any request in the queue has timed out. If so, the request is rejected and removed immediately. The distributor regularly checks if a slot is available. If so, the distributor requests the new session queue for the first matching request. The distributor then attempts to create a new session. Once the requested capabilities match the capabilities of any of the free node slots, the distributor attempts to get the available slot. If all the slots are busy, the distributor will ask the queue to add the request to the front of the queue. If request times out while retrying or adding to the front of the queue, it is rejected. After a session is created successfully, the distributor sends the session information to the new session queue. The new session queue sends the response back to the client. 6. Event bus. The event bus serves as a communication path between the nodes, distributor, new session queue, and session map. The grid does most of its internal communication through messages, avoiding expensive HTTP calls. When starting the grid in its fully distributed mode, the event bus is the first component that should be started.